Welcome to this tutorial on Kubernetes Cluster Autoscaler. In this video, we'll explore how to automatically add and remove nodes in your Kubernetes cluster based on demand. Cluster Autoscaler is a powerful feature that helps optimize your infrastructure costs while ensuring your applications have the resources they need. By the end of this tutorial, you'll understand how Cluster Autoscaler works and how it can benefit your Kubernetes deployments. Let's get started. Cluster Autoscaler is a Kubernetes component that automatically adjusts the number of nodes in your cluster based on resource demands. Think of it as an intelligent system that watches your cluster and makes decisions about when to grow or shrink your infrastructure. When pods cannot be scheduled because there aren't enough resources like CPU or memory available, Cluster Autoscaler adds new nodes to the cluster. On the flip side, when nodes are underutilized for an extended period, it removes them to avoid wasting resources. This automatic scaling optimizes your infrastructure costs by ensuring you only pay for the capacity you actually need at any given time. Cluster Autoscaler follows a simple three-step workflow. First, it continuously monitors the cluster, checking for unschedulable pods and tracking how much each node is being utilized. Second, it evaluates whether nodes need to be added or removed based on what it observed. This evaluation considers various factors like resource requests and scheduling constraints. Finally, it executes the scaling action by communicating with your cloud provider to either provision new nodes or terminate existing ones. This entire process runs automatically in the background, making real-time decisions to keep your cluster optimally sized. Let's dive deeper into the scale-up process. A scale-up is triggered when pods are in a pending state because there isn't enough CPU, memory, or other resources available to schedule them. Here's how it works step by step. First, Cluster Autoscaler detects unschedulable pods every 10 seconds by default. Second, it simulates which node group can accommodate these pending pods by testing different configurations. Third, it selects the best node group using what's called an expander strategy, which we'll discuss later. Finally, it requests the cloud provider to provision new nodes in the selected node group. Once these nodes are ready, Kubernetes can schedule the pending pods onto them. Now let's understand the scale-down process. A scale-down is triggered when node utilization falls below a certain threshold for a sustained period. Several conditions must be met before a node can be removed. First, the node must be underutilized for 10 minutes by default, though this is configurable. Second, both CPU and memory requests on that node must be below 50% of its capacity. Third, all pods running on that node must be able to be moved to other nodes safely without disrupting your applications. Fourth, there cannot be any pods with local storage or specific constraints that prevent them from being moved. Only when all these conditions are satisfied will Cluster Autoscaler remove the node. When Cluster Autoscaler needs to add nodes, it uses expander strategies to decide which node group to scale. There are four main strategies. The random strategy simply selects a node group at random when multiple options are available. The least waste strategy is more intelligent and chooses the node group that will have the least idle CPU after the scale-up operation, helping you maximize resource utilization. The most pods strategy selects the node group that can schedule the most pending pods at once. Finally, the priority strategy uses configurable priorities that you define to determine which node group should be expanded first. You can choose the strategy that best fits your infrastructure and cost optimization goals. Cluster Autoscaler has several important configuration parameters that control its behavior. The scan interval parameter determines how often the autoscaler evaluates the cluster state, with a default of 10 seconds. The scale-down delay after add parameter specifies the wait time before considering a scale-down after adding new nodes, defaulting to 10 minutes. This prevents the autoscaler from immediately removing nodes it just added. The scale-down utilization threshold sets the node utilization level below which scale-down is considered, with a default of 0.5 or 50%. Finally, The max node provision time parameter defines the maximum time to wait for a node to be provisioned, defaulting to 15 minutes. Adjusting these parameters allows you to fine-tune the auto-scaling behavior for your specific needs. There are two primary methods for deploying Cluster Autoscaler: auto-discovery and manual configuration. Auto-discovery automatically finds node groups that have specific tags in your cloud provider. It works seamlessly with cloud provider APIs and is the recommended approach for dynamic environments where node groups may change over time. Manual configuration, on the other hand, requires you to explicitly define node groups in the configuration file. With this method, you set minimum and maximum node counts for each group. Manual configuration is better suited for static, controlled setups where you want precise control over which node groups can be scaled. Both methods are valid, so choose the one that aligns with your operational preferences. To get the most out of Cluster Autoscaler, follow these best practices. First, always set resource requests for your pods. Define CPU and memory requests so that the scheduler and autoscaler can make accurate decisions about pod placement and node sizing. Second, use pod disruption budgets to protect critical workloads during scale-down operations. This prevents the autoscaler from removing nodes that would cause application disruptions. Third, monitor metrics related to autoscaling events, pending pods, and node utilization. This helps you understand how well the autoscaler is performing and identify any issues. Finally, configure node annotations, such as the Safe to Evict annotation, to control which pods and nodes can be affected during scale-down. Following these practices will help ensure smooth and reliable autoscaling in your Kubernetes cluster.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.